So guys, do you know the problems? So nearly the same picture, okay? So only the color of the skins are different. So here is white and here is black, okay? Okay, but somehow the results are totally different, okay? So this is one of the interesting examples how say that the machine learning or we say the computer vision is not perfect, okay? They cannot fully understand the situation. If you want to know more, go to the website. Is some sort is advanced racism, but it also proves that the machine learning, the computer vision, they are based on the distribution of color.
So after you have learned the machine learning, it's quite amazing, right? So you give the computer some input, some expected output. That means the image and also the label. So the computer can find the feature, so they can find the relationship, and then they can start to do the classifications for your image, and then put the correct labels for your image. Okay, but one of the most important thing is, yeah, computer is binary. That means 0 or 1, 0 or 1, 0 or 1. Okay, it can be numeric because the numeric number can be changed to binary number, but at least it must be some numeric. Okay, 1, 2, 3, 4, 5, 6, 11, 12, etc. Okay, so it comes to another problem: how to change the image. Okay, change the image that we have captured into numeric. Okay, into numeric data form. Okay, so we have another topic called comparisons. Okay, comparisons. Comparison is here, is a set. Okay, machine learning is here. Okay, so machine learning can handle different problems. They can handle the recommendation system. They can handle the AlphaGo. They can handle different kinds of problems. Okay, it's not only limited to the image. Okay, but they can also apply to the image. That means the comparisons. Okay, and then the deep learning that we are using is here. Okay, so deep learning here is the subset of the machine learning, and deep learning is also able to apply to comparisons. Okay, to solve lots of the different problems. But again, the first problem is how you can encode the image into the primary things. Okay, so here is our human brain, right? So we capture the image, we see the image from our eyes, and then we go to eyes is here. Okay, and then we process our the image, okay, by our brain. Okay, and then we can classify it whether it's an apple, orange, banana, or other kinds of object. Okay, computer, we have the similar flows. Okay, so we have the input. Okay, is the image, is the light, and then we use the sensing device. Okay, sensing device, we have different kinds of sensing device. It can be a camera, a webcam, a RGB camera, or RGBD camera. Okay, we will explain later. And then we change the this kind of image into some discrete signal. Discrete signal. That means we try to turn it all the thing into 0 and 1. Okay, I will explain later, and then process by the computer. Okay, so if you can turn the image into 0 and 1, so we can do lots of different kinds of things inside the computer, including the machine learning. Okay, so that is what we are going to study in this part and in this topic. So there are a couple of terms you need to understand before you go deep. Okay, so you need to understand what is your data source. Okay, so there are lots of the terms inside your data source. That means the image that you need to know. The first one is pixel. Pixel. Pixel is the smallest value of your image. So for all the image, okay, it will be transformed into lots of square. Okay, lots of square. Okay, so for each square here, we call it a pixel. Okay, a pixel. That when there is lots of the pixel together, it forms to image. Okay, it forms yeah, here we have the image. Okay, and when there are lots of image goes together, so we have the videos. Okay, so computer is like that. So we have different kinds of visual form together, and we have image, we have lots of different image, and then we have videos. So here is a image, okay, here is a image, okay, and then we try to encode each image into a digital signal, okay. So what we are going to use, we are going to use a color code here, color code, okay, just a minute, okay, color code, okay. So the color code, we have different kinds of color code system. So if it's a color code from lighting source, for example, your monitor, for example, the projector, they are producing the lighting source, then we use the RGB encoding, okay, red, green, and blue. If it's a printout, so we will use the CYMKs and other kinds of things, okay. And then we use the color code, and then we turn all the color into red, green, and blue. For all the color, we have a degree for it from 0 to 256. Okay, 0 to 256. Okay, 0 to 400. In fact, it's 255. Okay, so we have 256 value. It can be a 16-bit. So sometimes we use after 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go to A, B, C, D, E, F. Okay, so if there is a value called FF, okay, that means it's 255. Okay, so now we turn each pixel into a color code. Okay, so here we have lots of the color code, and all this kind of color code. Okay, so they represent a value from 0 to 255. Okay, so it becomes the numeric data. Okay, and we combine all the numeric data together, and we can use our machine learning, or we can use our deep learning extra inputs, and then put it into our new network model and then process. Okay, so there are different resolutions. Okay, because we have lots of different pixels, right? So for this image it should be 12, okay, times 16, okay, 12 times 16, okay, is the width and also the height of this image. So most likely for the webcams, it should be 320 pixels times 240 pixels, okay. So of course, if you purchase a better webcam, it can be a 720 pixel p, or HD 1080 pixel p, or even 4K, okay, even 4K. Again, if you have a better camera, so that you can capture more pixel at the same time, okay, but it also turns out you need to have extra computation power to process the image, okay. So if we combine lots of the image together, and then it becomes a video. So for the videos, we have the frame per second. That means for each second, how many image that we can process. So most likely in the webcam is 25 FPS frame per second. So this kind of image you need to bear in your mind, because when you are used for the training, or if you are using for the data processing, okay, if you increase the resolutions or increase the FPS, okay, it will exponentially increase your training times, okay. So don't think that if you get a 4K camera, so it's the best situations for your applications, okay. In fact, you are exponentially increase your computation power, and then you need unpredictable, unexpected time to train up the model, okay. It wastes your time. So for the hardware, there are two different kinds of camera. The first one is RGB, okay, red, green, blue camera. That means the webcam, that means the camera on your mobile phone, etc. Okay, it's a normal camera. It returns the RGB value. So mostly they have a higher resolutions. Okay, so even your webcam is 322 times 240. Okay, it's better than the RGBD depth camera. Okay. depth camera. So today, beside the RGB camera, we also front camera, right? So beside the RGB camera, we also have the infrared camera. That means the depth sensor, the depth camera, okay? To find out the 3D structure or find out the depth of the object, okay? So here is the depth of the object, okay? So in RGB camera, they cannot recognize the color. They can only recognize the depth, okay? So they know that this guys is in front of the camera, and then they can try to classify the background, okay, here, and also the human, okay? If your depth camera, they have a better resolution, so somehow they know the 3D structure of your face. They know the 3D structure of your object, okay? So it's quite good, especially we are doing some motion sensing, or especially is used for the security. For example, your iPhone and also the Surface Book or Surface Pro, maybe, yeah, Surface Pro, they have two camera, okay? They have two camera, because if you are using RGB camera only, so somehow some of the bad guys, they will capture your photo. It's easy to find your photo on social media, whatever is IG or Facebook, right? So they can capture your photos and then they can hack the camera. But if you have the depth camera, so somehow they will store the information of your 3D structure of your the 3D structure of your face, okay? So it makes the hacking, it makes the security become better, okay? They improve the security, okay? Because it's also collect the 3D structure of your face, so that you cannot just print the photos, or you use another iPad to cheat your camera, okay? It costs is lower resolution, okay? Most likely is 180 times 120. The resolution is lower, and it costs extra computation power to your PC, okay? And yeah, it only returns a single value. That means the depth, the distance between your camera and the real physical object, okay? But most likely, of course, for your deep learning, or for your Quizlet, so somehow you can also put the information of RGBD sensor if they have this kind of information, because for the RGBD sensor, it only provides the depth value, and then depth value is the distance, okay? It's the distance of each pixel. So it's also a numeric value. It's easy to put inside the network. But bear in your mind, not all the PC or not the clients, they have this kind of settings, okay? So you need to make sure that if you use the depth sensor, your application will be limited. So in computer vision, so there are lots of typical tasks, or we say applications, okay? Applications. So the commonly application is pattern recognition or image classification. That means your task, okay? Your task in this project. So you maybe want to recognize the not to $100, $200, etc. Right? Maybe you want to recognize some physical object, maybe apple, orange, or banana, etc. So this kind of thing we call it pattern recognition or image classifications. Okay. So there are lots of the things we can do. We can use the deep learning, we can use the feature extraction, etc. We can combine them together and use, okay? And then beside this kind of application that you will create in this project, so there are lots of different other applications. For example, the facial recognitions, okay? Identify the people in the photos, okay? Okay, so this is one of the good example that you need to use. Okay, so every day you unlock your iPhone by using your front camera and infrared camera. So this is one of the application. Or you use the camera to take the photo, right? So they will recognize the people face, okay, our human face, and then they will try to focus our human face when you are using the smartphone to take photo. Okay. So beside the pattern recognition or image classifications, we can also use the computer vision the motion analyze. Okay. So you can analyze the 3D widget motion, so you can analyze the movement of your body, okay? So you can also analyze some interesting points. So Kinect will be one of the interesting application, and all different kinds of VR applications, okay? VR applications will be also apply into this area, okay? And then you also have the scene understandings. That means when I capture an image or I have a videos, so they try to analyze all the object inside the videos and then tell you the meaning, okay, the meaning of this image. These kinds of setting, it really helps the VIP, visual impairment people, or we call it blind people. If you want to learn more, so you can go to the Microsoft Seeing AI. Google also doing the same things. So this is the project that how the VIP blind people can be helped by the technologies. Okay, so here is the link, so you can go to Google or YouTube, search this kind of information, and then have a look with the videos. It's quite amazing. Okay. So how to do the comparisons? Okay, so there are different kinds of method that you can do. Of course, you can use the machine learning. You can use the deep learning. You can use the CNN. You can use the Lab to do these kinds of things. Okay. But many years ago, when we do not have the deep learning, that not many years ago, it's only 10 or 15 years ago. So maybe we need to analyze the image and then by different AI methods and then extract the feature. Okay, extract the feature. This is one of the things that we do. And it also, computer visions also produce lots of the interesting pre-processing, okay, or enhancement application. For example, this is the image of our eyes, okay? Okay, this is the image of our eyes, okay? It's captured by Canon camera, I remember, okay? So we need to do some pre-processing before we put into deep learning or put into machine learning model. For example, we want to filter out the other information that is captured by the Canon camera, for example, here, right? We want to filter out all the things outside. We only want to the image. We only want the photo or the machine learning model to focus on the eyes. Okay, this part. Okay, and perhaps you can add some color filter to it, and perhaps you can scale. Where is it? Scale, rotate, or filter out some interesting or some important pixel to the machine learning model. Okay, so this kind of things we have to do it, and then we need to do it. Okay, and then there are lots of different kinds of things. So you can also try the detections or segmentation. Okay, so computer visions, besides using the deep learning or machine learning, there are lots of different methods how to do the segmentation. That means try to separate the object. Okay, so we can here separate the object. This one is human, and then we have the foreground, we have the background, we have the tree, we have the car, etc. So this kind of applications is also, or this kind of method is also commonly used in computer visions. And in your project, perhaps you use the computer visions, right? And then don't think that machine learning, they are all the things. Sometimes you need to set up a good physical environment for the machine learning to capture the image data. You need to scale, you need to rotate, or somehow you need to let the machine learning to learn the background first. Okay, to learn the background or foreground first before they start the learning. Okay, always remember this kind of pre-processing or this kind of enhancement, we help the machine learning. It speed up all the process and increase the accuracies for your model. Okay.
Then for the replacement of empty questions, so besides using the computer vision to recognize the object from the webcam, we can also use the audio input. And then the API that we are using is Google Dialogflow. Okay, Google Dialogflow. Yeah, Google Dialogflow. Again, it's a PaaS. So he provides the API, he also provides the platform, okay, infrastructure for us. That means the server for us to call. So a easiest understanding about Google Dialogflow is chatbot. Okay, chatbot. So you try to solve the linear constellations. That means the most likely the chatbot is only about Q&A. Okay, Q&A pair. So you detect the keywords inside the questions and then you provide the corresponding answer. Okay, but Google Dialog Flow, it turns from this kind of linear conversations into some agent-oriented approach. That means you can allow multiple staff or multiple person to input their thinking. Okay, their thinking into a model and then combine their thinking into one. Okay. So another easy understanding about this kinds of Google chatbot is it provides virtual agents. Okay. When they talk with a real person. Okay, through the telephones or through the Facebook or through the other customer service. Okay, you type in the information or you use your speech to talk with them, right? So they return the speed. Okay, they return the speed to task. Okay, again they do the keywords understanding. So we'll discuss later about what to test and other features to test, etc. Okay, and then they try to understand the meaning behind. So they have sentiments analyzed. Okay, so they try to understand the emotions. They try to understand the questions behind the behind the question. That means the situation of the user. Okay, and then identify the exactly problem. Okay, so it's a subjective options. Then after the analyze, so they will try to find out the answer. Most likely the chatbot is going to find an answer. So you need to do is prepare lots of keywords and answer pair. And the answer is only text. Okay, so they also provide text to speech. Okay, so if it's a chatbot, or in this project you are going to use Cantonese or other language to discuss with the end user, so you need to turn the keywords into the speech again. Okay, and dialog flow, there are two different kind of versions. Most likely we will use the ES, essential versions, the standard one. So essential version is pretty good. They provide enough structure for you, okay, enough API for you. But if you want to use some advanced one, so CS, okay, CX, it also provides lots of different possibility for you. We'll discuss their difference later. So here is the UI of the dialog flow, okay, so again, they provide the GUI is good. So the only thing you need to do is somehow train up the model. Okay. What is the start, and then what kind of questions that you are going to prepare, and then what kind of answer that you are going to prepare. Okay. So it's still a kind of state machine, but involve more intelligence inside it. So the CX and then the ES, okay, essential, and also the customer experience. So the main difference between the ES and CX is about the support. Okay, so mostly the essential one, they provide 40 plus, and then customer experience, they provide 9 agents for you. Okay, so why the essential one, they provide more? Okay, so 40 here and 9 here. Okay, the difference between the essential one is somehow essential is only provide some ready to use and some basic function. Okay, so they provide the dining out, they provide the hotel booking, navigation, IoT, etc. Okay, there are lots of template. But it's a customer service, right? Customer service. Most likely you want to build in lots of your customized solutions, customized answer. Okay, customized answer. So you want to have your flexibility to build your agents. Okay. And then the CS, they provide more flexibility for you to do it, okay, unlike the essential one. But for our project, essential one is pretty good, okay, it's pretty good. So because most of our question is only simple question and answer, and maybe only contain few question and answer pair. So essential one is good enough for you. So you do not have to build a huge state machine to do it, okay. So what you are going to do is here, so it's easy to understand. So CX or EX, they also provide two things. So you can have the voice input, okay, or you can have the text input, okay, text input here, sorry, text and a voice, okay, for the telephone or throughout the internet, both are accepted. Then they will pass to download fold. So they will use some speak to task, or they use the task to find out the information that you want. And then for the database, you need to develop your fulfillment. Okay, here question and answer pair, and then they will match the information according to your database. Okay, and then file a pair up and perform the action, return to the user, etc. So again, another thing you need to bear in your mind is all the surface is chart. You need to page for Google. Okay, so for the essential one is easy. So most likely you will in this project, most likely you can enjoy the free surface, and then most of the surface here is free. Okay, trial versions. Okay, essential edition, most of them are free, and then it's pretty enough for your use. And then for the 6th version, so it charge per request. Okay, wherever is task or wherever is audio input output, speed to task or task to switch. Okay, so it charge for some money. Okay, so again in your lab exercise, it's better to create a new Google account and test this kind of service instead of using your personal account and then try it. Okay. So the technology is behind the chatbot, and also behind the Google Dialogflow is the natural language processing, NLP. Okay. So I'm not the expert of the NLP. So Maggie, she's the expert. But most likely she can answer more. Or if you want to study more, you can go to the natural language processing class and then study. So the easy understanding about the chatbot, okay, chatbot is one of the killer applications of the NLP, natural language processing. Okay, so natural language processing include different applications. They have the speech recognitions. Okay, so how to recognize the wordings according to according to the meaning of the whole sentence. Okay, they also have the speech segmentation. So we continue to speak something, right? So how to separate the sentence and then draw the keyword from our sentence, because most of our conversation, right? Most of our wordings are rubbish. Okay, so how to get out the N word, okay, get out the rubbish wordings and then get the keywords is one of the important thing in NLP. And of course, text to speech. So many years ago, the text to speech is really inhuman. Okay, it's not easy to understand by human. You feel it's like a machine to speak with you. But if you now go to Google Dialogflow and then just search the YouTube, okay, search on the YouTube, and then about the Google Dialogflow application. So it's really natural. Okay. NLP and machine learning. Okay, so machine learning is here, NLP is here. Again, it's two different kinds of domain. Okay, so they have the overlap. So you can use the machine learning algorithm to solve some of the natural language processing problem. Okay, and there are two algorithms that is very useful to use. One is word to word. Okay, so they transfer the wordings into a numeric data, into a vector, okay, numeric data, and then they put the similar wordings, okay, with the similar meaning in the same cluster. So word to word is somehow we try to put the English character into some numeric data, okay, and then we find out the similar meanings within the same English wordings. Okay, so for example, what is here, woman and man, they are in the same category. Queen and king, they are similar. Okay, so they provide similar situation. That means we can use the similar algorithm to understand, or similar answer to understand this kind of wordings. Okay, another one is face to word. So it's similar, but it focuses on the sentence. For example, here we have the similar sentence. Okay, the most difference or the main difference is about the locations. Okay, and this one, they measure the difference between the sentence and then find out the keywords that you are going to ask. Okay, so if you, again, I'm not the expert. If you want to know more, it's better to study the natural language processing.